Welcome back, third grade friends. It's Mrs. Hoffman again. When we were together last time, we did some subtracting using base 10 blocks. Today we're going to subtract a different way. We're actually going to use counting up or counting on to help us subtract. You're going to need a couple of things for our lesson today. You're going to need your student guided practice page. It looks like this. It's got all those lines on it, and I'm going to tell you why in just a moment. And then you're going to need a pencil. Double check, make sure it has an eraser, or you've got one of those big fat pink erasers handy because you might need it. Remember, in math, mistakes are okay. It's how we learn and grow. So today, before we get started, to get our brains going, we're going to do a quick refueling break using mountain breathing. This is one of my very favorites. There's a couple of ways you can do this. You can just follow along with me and watch as I move my hand along the drawing, or if you want, you can draw your own mountains. Just take your paper, turn it over, grab your pencil, and as you're drawing those mountains, you're going to take those nice big deep breaths with me. We're going to do this one time today. We're going to start over here, and as we go up the mountain, we're going to take a nice big deep breath in. We're going to stop and hold it at the top for just a moment, and then let it out as we come down. And if you notice this big mountain in the middle, that's going to be our biggest, deepest breath. So make sure you're ready for that one. Okay, here we go. We're going to take our first big deep breath. We're going to hold it. Let it out. Let's take another big deep breath, a little bit bigger this time. And hold it. Let it out. Remember, this is your biggest, deepest breath. Here we go. Hold it at the top. And let it out. We're going to take just a smaller deep breath. Here we go. Hold it. And let it out. Last big deep breath. Make it count. Here we go. Hold it at the top. And let it out. There we go. Now that our brains are ready to go, let's take a look at our goals for today. We're still subtracting within 1,000, but this time we're going to use an open number line. Have you ever heard of an open number line before? You may not have, but I bet you've seen a number line. Most number lines look like this. They start at 0 or 1, and then they go up to 10, or this one even goes up to 20. But the neat thing about number lines is they can go on and on and on forever in both directions. And they can start and end anywhere we want them to. So an open number line is simply a number line where we choose the beginning and the end of the number line. So for example, if I wanted to draw a number line, I would draw a straight line with arrows on the end. And maybe I want my number line to start with 15, and I want it to end with 35. There's my open number line. It can begin where I want and end where I want. Okay? All right, so let's watch just a quick video, and we're going to kind of see how this number line works. I want you to pay really close attention, and then we'll come back together in a moment.
Nabisco produces 688 tons of Oreos every day. It also produces 371 tons of Ritz crackers. How many more tons of Oreos are produced each day? In this lesson, you will solve subtraction problems by finding the distance between two numbers on a number line. Let's review. You already know that when you subtract, you are finding the difference. The difference between two numbers is the distance between them. You can see this on a number line. Take 7 minus 4. 7 minus 4 can be represented as the space or distance between 4 and 7. If you count the distance or the spaces between these two numbers, you find that 7 minus 4 equals 3. The difference is a distance of 3 units. You can use the same method to find the distance between larger numbers. Let's say I want to find the difference when I subtract 87 from 243. I can actually create my own number line. All I need to do is draw a straight line with arrows on either end. This is called an open number line. There are no marks already on it. I'm going to make my own marks. My starting point will be 87 and my end point will be 243. How is this going to help us find the difference? Well, let's think about what we know. We know that on number lines we count hops, not marks. We also know that there are some friendly numbers between 87 and 243. For example, 100 is a friendly number between 87 and 243. Let's hop from 87 to 100. Now, I need to think about how far I just hopped. If that's not something you can figure out quickly, your first hop can be even smaller. I can hop 3 spaces from 87 to 90. Then 10 more spaces to 100. So I just hopped a total of 13 spaces to get to 100. Let's hop to another friendly number, 200. That was an easy hop of 100 spaces. And finally, from 200 to 243, we know we just need to add 43. Let's look at the total distance we traveled. 3 plus 10 plus 100 plus 43. Now I have an easy addition problem that I can rewrite vertically or solve in my head. I find that the distance between 87 and 243 is 156. So 243 minus 87 equals 156. A common mistake is to take too many small hops, which will get you the correct answer, but will be time-consuming. Imagine you're subtracting 508 minus 42. If you hop from 42 to 50 to 60 to 70, etc., you'll have more to add and you'll waste time. It's more efficient to hop from 42 to 50 to 100 to 500 to 508. Fewer moves is always faster, and it leaves less room to make a mistake. Let's go back to our original question. Nabisco produces 688 tons of Oreos every day. It also produces 371 tons of Ritz crackers. How many more tons of Oreos are produced each day? This is asking, what is 688 minus 371? I will start to solve this by drawing in my open number line. I'll make my first point at 371 and my end point at 688. Now I will figure out what the first friendly number I can get to is. 371 plus 9 is 380. 380 plus 20 is 400. I can get from 400 to 600 by adding 200, and then 600 to 688 is just 88 away. Now let's add our hops. We can line them up vertically, or if you wanted, you could try adding in your head. 200 plus 88 plus 20 plus 9 gives us a total of 317. 688 minus 371 equals 317. In this lesson, you have learned how to solve subtraction problems by finding the distance between two numbers on a number line.
Okay, so that was a lot of little steps. It's going to take us some practice to figure out how this works. So let's go nice and slow. Let's take a look at our first number line. Now if you notice on the first number line, our first problem is 352 minus 197. So on your paper, you've got that nice big long line. I want you to put an arrow on each end. We're going to start our number line with the number we're subtracting, our smaller number. So we're going to start this number line with 197. So go ahead and put a little dash mark there and put your 197. At the end of your number line, all the way over on this right side, we're going to put our big number, the number we're subtracting from. So you're going to end that number line with 352. Now our job is to find the difference between 197 and 352. Well, let's think about this. I need to hop to some friendly numbers. So I know that 197 is pretty close to 200. How many numbers are between 197 and 200? Well, let's think about this. We've got 197, 198, 199, 200. So if I put the number, let's try this. There we go. Put the number 200 here. That's a distance of 3. Do you agree? Perfect. Well, now I'm at 200. Let's look at our 100 over here. How many hundreds do I need? Yeah, I need 300. So I'm going to come all the way over here and I'm going to put the number 300. What's the difference between 300 and 200? How far is between those two numbers? Well, I think to go from 200 to 300, I've got to hop a distance of 100. Well, now I want to find another friendly number here. So I'm going to go from 300 to 352. Well, I think if I go from here to here, that's just simply 52. So now to find the total distance between 352 and 197, I just need to add those numbers. And remember what we said about using the commutative and associative property a few days ago to change the order of our numbers and make them simpler to add? Well, 3 is pretty simple and 100 is pretty simple. But 52 has tens and ones. So I'm actually going to break that number up into 50 and 2. So I have 3 plus 100 plus 50 plus 2. Now, can we use our commutative property to rearrange those numbers and make it easier? I think we need to put our ones together. Let's do that. So I'm going to write 2 plus 3, and then I'm going to do my tens, and then I'm going to put my hundreds in there. I'm going to use my associative property to group those like numbers. So I'm going to put these together. All right, so now I've got 5 and 50 and 100. Now, even though my ones are first, let's think backwards. If I read this number and I squish it all together, I've got 155. So the difference between 352 and 197 is 155. Do you see how that works? Let's try another one. Let's get a little tougher here. 300 minus 145. On that number line, we're going to start our number line, that open number line, with 145. We're going to end it all the way down here with 300. So go ahead and put your arrows on the end of your number line. Mark your beginning at 145 and your end at 300. And let's think carefully. I need to find a simple, easy, friendly number to get from 145 to something that's simpler. Well, I'm thinking a friendly number that I know is 150. How many did I have to hop to get from 145 to 150? Are you thinking 5? I know I am. Now, I'm at 150. I want to find a simple, friendly number to get me closer to 300. Well, I know that 150 can get me to 200 if I make a hop of 50. So from 150 to 200 is 50. Well, I'm at 200. I need to get to 300. Well, that seems like a pretty easy jump. If I go from 200 to 300, that's just 100. That wasn't too bad. Let's rearrange these numbers. Let's write our hundreds first, then our 50s, or then our 10s, and then our ones. And let's see if we can figure out what our answer is. So I've got 100 plus this jump of 50 plus that jump of 5. And the reason we can write them that way is because of that commutative property that says we can put them in any order we want. This makes it easier for me visually to see my answer. So if I squish those all back together, I've got 155. Well, that was a happy accident. Wasn't that the answer to our last problem? My brain must have been thinking about 5s. Let's try another one. Okay, 676 minus 259. My number line is blank. How am I going to figure out where my number line should start? Should I start at 0 or 10? How do I know where to start? Right, you're going to find that smaller number. What we're taking away is 259. So that's where we're going to start our number line. So let's write that, 259. Well, where do I need my number line to end? How do I figure that out? Yeah, I'm going to look at my problem and I'm going to figure out what number I'm starting with, 676, and I'm going to put it at the end. This seems like it might be a tough problem. Remember, the common mistake we can make is to make too many little jumps. So we want to think as big as we can without confusing ourselves. But I'm thinking that my first jump might be a really small jump. Look at the number I'm starting with, 259. Well, that's really, really close to 260. That's only a hop of 1. Is that okay sometimes? Absolutely it is. So let's do that. Let's write 260. Now remember, that's just a hop of 1. It's just one little jump there. What would be our next friendly number? I'm at 260. I want to get to an even 300. What do you think is going to be the best way to get to 300 without making too many hops? Can you count by tens? How many tens are between 260 and 300? Let's count that. 260, 270, 280, 290, 300. So each of those is a 10. 10, 20, 30, 40. So if I go from 260 to 300, that's a hop of 40. Well, that's not terrible. Okay. Well, I'm at 300. I want to stay in the hundreds as long as I can. And I want to get as close to 676 as I can get. Where should I stop? Where should my next jump be to? Are you thinking 600? If you are, then you're right on. I know some people might have been thinking 700, but if I jump all the way to 700, I'm going to go right past my 676. And while that number is close to 676, it's too big. So let's hop all the way over here to 600. What's the distance between 300 and 600? So let's count. Let's think in our head 300. We're going to count by hundreds. So 300, 400, 500, 600. If each finger represents 100, how many hundreds did we jump? Perfect. We jumped 300s. So here we go. Now I'm at 600. I want to stick with friendly numbers so I don't have to break anything apart. So I want to go and make my next jump be 670. So if I'm at 600 and I go to 670, how many do I jump? Yeah, that was an easy one. I'm going to jump 70. Okay, I've got one more little jump to make. I'm at 670. I have to go to 676. How many am I jumping? Yeah, just a little hop here to 6. Okay, let's use our commutative and associative properties and let's put all these numbers together. Let's start with our hundreds. So when I look across the top here, how many hundreds do you see? Perfect. I see 300, so I'm going to grab that 300. I'm going to put it over here. Okay, let's put our tens together. So when I look for tens, I see 40 and I see 70. So let's put those together next to each other. Doesn't matter which one you put first because the commutative property says I can do either one first. All right, now let's look at our ones. So I see a jump of 1 and I see a jump of 6. So I'm going to bring those down here. Okay. Let's use our associative property and group some numbers. I'm going to group my tens together, and I'm going to group my ones together. My 300's all alone, so I'm just going to keep it like it is. 300. Oh man, look here at this number. 70 plus 40. We're going to count by tens. We're going to start with 70, and we're going to count up by tens 4 times because 40 is 4 tens. So 70, 80, 90, 100, 110. So here I have 110. Ooh, that might be a tough one. And then when I add my ones together, 1 plus 6 gives me what? You got it. It's going to give me 7. Okay. Now this one's a little tricky, but let's see what we can do here. 300 plus 100 is 400. 300 plus 110 is 410 plus 7 is 417. Okay, now I'm going to let you try one. Remember, if you take too many hops, it's fine. It's just going to give you more room for errors. So try to think as big as you can. Remember, when you're jumping between tens, you can count by tens. When you're jumping between hundreds, you can count by hundreds. Take your time. Find the easy numbers, the friendly numbers first. Remember that your problem is going, or your number line is going to start with your small number and it's going to end with your large number. All right, here we go. Take just a moment and try this one. All right, let's see how you did. First of all, let's see if your number line starts and ends with the same as mine. I'm going to start my number line with the number 359. Did you do that? Spectacular. Did you end your number line with 738? If you did, nice big pat on the back. Now here's something to think about. When I solve my problem, I might do it a little differently than you. That's okay. Remember, the cool thing about math is there's more than one way to solve the problem. So if I make a different jump than you do, I don't want you to panic or worry. As long as your answer matches mine at the end, then we're all okay. So I'm thinking that my first jump is going to be an itty bitty one because I'm starting at 359 and I know that the next friendly number is 360. So I'm going to make that one little jump right here. My next jump is going to take me to 400. So I'm going to put that 400 here. And I know that that jump from 360 to 400 is 40. So I've jumped one single time and then I've jumped 40. Now I'm going to stay in those hundreds. I'm going to go all the way from 400 to 700. So I know that that jump is going to give me 300. Now this next part might be where we differ just a little bit. So I'm going to go from 700 to 730. And I know that that jump gives me 30. Now I'm going to go from 730 to 738, which I know is 8. I'm going to use my commutative property to rearrange these numbers and put my like numbers together. So I'm going to start with that 300, and then I'm going to grab the ones that are 10s. So I'm going to grab the 40 and the 30 and put those together. And then I'm going to grab my single ones, my units. I'm going to grab my 1 and my 8, and I'm going to put those together. So I've used my commutative property to rearrange the numbers to make it easier. Now I'm going to group my numbers using the associative property to then go back and add. So I'm going to group my 10s, and I'm going to group my 1s. Why didn't I group my hundreds? Yeah, because there's just one. Okay, so I'm going to keep that 300. I'm going to add 40 plus 30, which I know gives me 70. I'm going to add 1 plus 8, which I know gives me 9. Now I can easily take that expanded form, squish it back together, and I should have gotten 379. If you got 379, you need to be so proud of yourself because this is the hardest math. It is so difficult. Math is not easy, so give yourself a nice big pat on the back. If you miss this problem, that's okay. We can go back and try again another time. In the meantime, though, I have a really fun way for you to make numbers. You can do this at home all by yourself. All you need to do is draw 1, 2, 3, 4, 5 circles. 6 circles. Don't forget that little one in the middle. And each circle is going to be a little bit bigger. Then you're going to randomly take your numbers, 0 through 9, and put them anywhere in here. That special bullseye gets a question mark. If you land on that question mark, you can put any number you want. So here's how this works. You're going to take a crayon, colored pencil, marker, something like that, and you're going to close your eyes, and you're going to move your pen back and forth, and you're just going to stop. And wherever you stop, that's the number you choose. So I'm going to choose the number 8. I'm going to do it again. I'm just going to go across and back and across and back, and wherever I land, that's the number that I choose. If you do this with a marker, it works best. You just drop that marker right down on it. So I'm just going to make my number. I'm going to pretend I got 826 minus 539. Then you can practice using your open number line to subtract these numbers. Do your very best work. And remember, if you can explain it to someone else, that means you are a pro. Today's code word is pool because that is where I would like to be right now, in the pool. And I hope you have a wonderful afternoon, and I will see you next time. Bye.